Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at the topic of relations and functions in CSEC Mathematics, and specifically the past paper questions from May 2014 until 2018 in paper 2. Feel free to like the video and add any comments down below so we can create other videos to help you in whatever areas that you are struggling with. Don't forget to look at the description down below, which gives an overview of the entire CSEC Maths syllabus and all the solutions from May 2009 until the present. If we look at the major topics in CSEC Mathematics, we'll see that there are 10 of them, and this video will be concentrating on topic number 7, relations, functions, and graphs. This topic is tested for 8 questions out of the 60 in the multiple choice paper 1 and for 20 marks or 2 full questions out of the 10 questions in paper 2. This video will be looking at this topic, which has been broken up into 2 parts, into section 1 and section 2, 1 question each. This video looks specifically at the questions in section 1 of the paper, which has come over the last 5 years from 2014 until 2018. May 2014, number 6, the graph of the quadratic function y equal to x squared for minus 4 is less than or equal to x, which is less than or equal to 4 is shown below. So if you look at our graph, which is given, we can see that the quadratic, the curve, the parabola, has been drawn with the least value of x being minus 4 and the largest value of x being plus 4. That's what it means for that domain to be from minus 4 to plus 4. Part A, the coordinates of the points m and n are minus 1, 9 and xy respectively. Determine the value of x. So if we go to the point n and we want to get the x coordinate here, we just need to come straight down. We have a line there indicating that x is equal to 3. From the x-axis. And for part 2, we need to determine the value of y. Now, y comes from the point m, and m lies at minus 1, 9. So if we want to get the y value, we need to go at m and go across. Now, if you notice, it's not hitting an exact value there. So how do we determine this? The graph just helps us to know that it's somewhere between 0 and 3. So what do? We have a function. Let's write the function y is equal to x squared, and we know the value of x at that point, which is minus 1. So we can substitute y is equal to minus 1 squared, and minus 1 times minus 1, 1 ones are 1, a minus and a minus, 2 signs which are the same, the answer is positive. So y is equal to plus 1. And we don't need to write the plus is understood. Part B, determine the first part, the gradient of the line mn. So let's draw the line mn in brown, and let's recall the formula. M is equal to change in y over change in x. I mean, there are other ways to write the same formula, y2 minus y1 over x2 minus x1, or rise over run, and so forth. So how do we do this if we have a graph? Well, we take out of the 2 points, we take the point on the left, and we try to move until we get to the point on the right. So we're starting with m, and let's draw a purple line going to the right. And how far does it go? It moves from minus 1 until it reaches 3. So it moves 4 to the right. And when it reaches there, it now has to go upwards. So remember the y value that we worked out in part A, part 2, it was 1. So it's moving from 1 and going upwards until it reaches 9. Therefore, the change in y is 8. So let's substitute. M is equal to 8 over 4. Therefore, m, which is the gradient of that line, is 2. So we just found the gradient of mn. And if we look at it, we can see it's cutting the y-axis, or it's the y-intercept is 3. Part 2 of the question now. The equation of the line mn, that's what we need to determine. So if we need to get the equation of a straight line, let's write the general formula for all straight lines. Y is equal to mx plus c. And do we know m? Yes, we do. We worked it out in part 1 to be 2. And do we know C? C is our y-intercept, where it's cutting the y-axis. And we can tell from the graph that it's cutting at 3. Therefore, we just need to substitute. So y is equal to 2x plus 3. Part 3 of the question. The equation of the line parallel to MN and passing through the origin. So we need to find an equation of a new line, a line parallel to the brown line MN. So let's write the general equation of straight lines. Y is equal to mx plus c. And if two lines are parallel, it means that the gradient m is going to be the same. And where will this new line cut the y-axis? It's passing through the origin, which means it's cutting the y-axis at 0. So we can substitute. We'll get y is equal to 2x plus 0. And we don't need to write the 0, so we can just simply write it as y is equal to 2x. And that's the equation of the line parallel to MN passing through the origin. And for part C, on the answer sheet provided, that's that graph, carefully draw the tangent line to the graph y is equal to x squared at the point 2, 4. So let's go to 2, 4. That's a point on the curve, on the parabola. And let's put our long ruler there and adjust the ruler slightly so that we can draw a line where it's touching that curve only at one point. So let me draw the line like I have it in green there. Right, that indicates the tangent line. Now for the last part, part D, estimate the gradient of the tangent to the curve at this value, 2, 4. So in order to get gradient, we wanted to consider 2 points. So let's insert a point on the left side in yellow or orange, and then one on the right side, which lies on the green line. How do we get the gradient? We have the formula written above in B part 1, the change in y over the change in x. So let's move from the bottom left side one to the top right points that we've just put in. So if we draw the red line going across, we're moving from 1 to 5, so we're moving 4 places to the right. So now that we have plus 4 units there for the change in x, when we reach there, we need to go upwards. And we're going from 0 until we reach 15, so therefore the change in y is plus 15. Therefore, the estimated gradient will be change in y over change in x, which is 15 over 4. May 2015, number 4. A graph sheet is provided for this question. The table below is designed to show the values of x and y for the function y is equal to x squared minus 2x minus 3 for integer values of x from minus 2 to 4. We can see x and y values from minus 2, 5, and going up till 4, 5. So just to help out students who are getting problems understanding what's happening here, let's draw a flowchart so we can put in the input as x. And how do we follow that formula there? Y equal to x squared minus 2x minus 3. So if the input is x, the first thing to do is say x squared, square the x, and then take away or minus 2 times x, and then minus 3, and that will give us our output, our y value. So whatever number we put in as the input, let's say minus 2, plug it into here, we'll get our output as 5. That's how we got our first point, say minus 2, 5. Part A, copy and complete the table below. And what's missing to complete the table are 2 values. The values when x is minus 1 and when x is 3. So let's write the formula, substitute and solve in both cases to find them. So we have the formula. It was given y is equal to x squared minus 2x minus 3. And let x be equal to minus 1. So if we're substituting, we're going to get y is equal to minus 1 squared minus 2 by minus 1 minus 3. What we're doing is directly substituting. And minus 1 squared works out to be 1. Minus 2 times minus 1, 2 ones are 2. A minus and a minus will give us a plus. Minus 3. So 1 plus 2 is 3. 3 take away 3 is 0. So we can say that at x equal to minus 1, y is equal to 0. For the next point that's missing, let's write the formula again. Y is equal to x squared minus 2x minus 3. and x is equal to 3 at this point. So when we substitute, we're going to get y is equal to 3 squared minus 2 times 3 minus 3. So 3 squared is 9. 2 3s are 6, so 9 minus 6 minus 3. 9 minus 6 is 3, 3 minus 3 is 0. So at both these y values that were missing, they worked out to be 0. Part B of the question, the last part, plot the graph y equal to x squared minus 2x minus 3 using a scale of 2 cm to represent 1 unit on the x-axis and 1 cm to represent 1 unit on the y-axis. Complete the following sentences using information from your graph. So now that we're given this blank graph page here, we take our long ruler and draw our x-axis. Don't forget to label x, and our y-axis, labeling y. And where they meet is at the origin, so we label that 0. And if we want to plot the values on the x-axis first, let's look back at the scale. For every 2 centimeters, we represent 1 unit. So from 0, we move 2 centimeters to the right, we'll get 1. Another 2 centimeters, we'll get 2. Another 2 centimeters, 3. Another 2 centimeters, 4. And if you're going to the left, we'll get minus 1 and minus 2. And how do you plot the scale on the y-axis? 1 cm to represent 1 unit is given above. So from 0, if we go up 1 cm, we get 1, another cm 2, and continue, up to at least 5, and come down from 0, minus 1, minus 2, until minus 4. Because if we look at our at our table on the left-hand side, we can see the least value of x is minus 2, and the largest value of x is 4. So we want to make sure our x values include minus 2 and 4. And if you have more room on your graph paper, it would be better to add 1 extra point on the left and right. Let's plot the graph. So we need to take the points, minus 2, 5, and put it in, minus 1, 0, 0, minus 3, 1, minus 4, which is the lowest point on the graph, 2, minus 3, 3, 0, and 4, 5. And let's connect the dots. And that is plotting the graph. That's worth 4 marks. B part 1 now, the values of x for which y is 0. So how do we do that? When y is 0, those are the roots of the equation, means where does the graph cut the x-axis? It cuts it at, I'll put 2 arrows to indicate there. It cuts it at x is equal to minus 1 and x is equal to 3. For part 2 of the question, what is the minimum value? And the minimum value means what is the y value, the smallest y value that this graph obtains. The smallest value would be at the lowest point, and let's put an arrow showing you it's at the point 1 minus 4. So the minimum value is minus 4. Y does not get smaller than minus 4 in this graph. For part 3, the last part of the question, the equation of the line of symmetry of the graph of y is equal to x squared minus 2x minus 3 is, so how do you get the line of symmetry? If we look at our quadratic, we can see that we can fold it evenly, and there's a mirror line or an axis of symmetry or a line of symmetry. They all mean the same. And I'll put it in green, so we can see where is that line. That line is passing through x equal to 1, and that's the mirror line. May 2016, number 6a. The diagram below shows the graph of the straight line x plus y is equal to 3. So we have this line in black. Determine the equation of the line which is parallel to the line x plus y is equal to 3 and passes through the origin. Let's have that line in green. And we want to be able to get this line shifted down. It's parallel but passing through the origin. Now what's the same? What we can tell is the slope is going to be the same. Now it's a little difficult to maneuver this equation as the form is x plus y is equal to 3. So let's rearrange it to look like a standard general equation of a straight line. Y equal to mx plus c. So how do we do that? If x plus y is equal to 3, we want y alone on the left hand side. The x on the left side is adding when I carry it across, it will minus, so we'll get y is equal to minus x plus 3. So this looks like the general equation of a line. Now it's the same as x plus y is equal to 3, we just rearranged it. The line is cutting the y-axis at plus 3. And if we look at the diagram, we can see that. And we can also tell the gradient is minus 1. Remember, it's mx plus c. M is the gradient or the number in front of the x. As such, for this parallel line now, let's write the general formula y is equal to mx plus c. And we know a couple things. One, they are parallel, the green line and this black line. So the gradient is minus 1. And it's cutting at the origin. It's cutting where y is 0. So we can substitute. We're going to get y is equal to minus x plus 0. And there's no reason to write the 0, so we can leave it out and let's simplify it as y is equal to minus x. That's the equation of this parallel line that's passing through the origin. For part 2, determine the equation of the line which is perpendicular to x plus y is equal to 3, to the original line, and passes through the midpoint of AB. So one of the first things to do is find the midpoint of AB. Let's put that up as a yellow cross to identify approximately where it is. So maybe we can tell this off from the graph quickly. Let's do some working. If we want to find the midpoint of a AB, remember, let's look at the x values. We know A and B, so we get the middle of A and B x values. How do we get the middle of two values? We add them up and divide by 2. Or find the average. Same thing. So the midpoint of AB would be the x value of A plus the x value of B divided by 2. And we're going to do the same thing with the y values. So if we substitute, we're going to get the midpoint of AB is 0. That was the x value of A. And 3, the x value of B, all over 2. And the y values are, for A, the y value is 3. And the y value for B is 0. So let's solve. 0 plus 3 is 3. 2 into 3 is 1.5 for the x. And 3 plus 0, same thing, is 1.5 for the y. So the midpoint of AB, this little yellow x that we have, is 1.5, 1.5. Equation of this perpendicular line, let's bring that up as a yellow line there, running at perpendicular means 90 degrees, passing through the midpoint. So how can we determine that? Well, what we remember is that if we have two lines which are perpendicular at 90 degrees to each other, and we multiply their gradients, how steep they are, we're going to get minus 1. So let's write that. Minus 1 is the gradient of AB, the original line which you have in green, times this gradient of this new AB, this perpendicular line which you have in yellow. So let's substitute. Minus 1 is equal to, do we know the gradient of AB? We worked that out from part 1 of the question. That is minus 1 times the gradient of this perpendicular AB. And if we want to get rid of the minus 1 on the right hand side, we carry it across. And that will give us minus 1 over minus 1, which is 1. So the gradient of the perpendicular line AB is plus 1. Now find the equation of this line. So let's recall the gradient of any line is change in y over change in x. And we know for this particular yellow line, the gradient is 1. We just worked that out. And that will be equal to y minus, and let's use the values of the midpoint of AB, because that is a point on that yellow line. So what's the y value? 1.5. So y minus 1.5 over x minus, what's the x value? 1.5. We worked that out in red above. Let's make y the subject of the formula. So let's carry the denominator, those brackets across. So it'll be 1 times x minus 1.5 is equal to y minus 1.5. And let's expand the brackets. 1 times x is 1x. 1 times 1.5 is minus 1.5. Let's simplify now. Let's keep y alone on the right hand side. We're trying to make it look like the general formula of a straight line. So we have minus 1.5 on the right side. If we carry it across, it will add. So we're going to get x minus 1.5 plus 1.5. And minus 1.5 plus 1.5 is 0. So we're left with y is equal to x. And that's the equation of the perpendicular line passing through the midpoint AB. May 2016, number 6b. The function y equal x squared minus 2x minus 3 is defined in the domain minus 2 less than or equal to x, which is less than or equal to 4. The table below shows the corresponding values of y for 5 selected values of x. So if you look at the table, we can see from minus 2 straight up to 4, which is what was identified in the domain above. And those are 7 items, so 7 values of x, and they gave us 5 y values, meaning 2 y values are missing. Part 1. Complete the table by calculating and inserting the missing values of y. So, let's write our formula, substitute and solve for the point where x is equal to 1 and where x is equal to 3. Y equal to x squared minus 2x minus 3. Let x be equal to 1. So if we substitute, we get y is equal to 1 squared minus 2 by 1 minus 3. 1 squared, 1 ones are 1, minus 2 ones are 2, minus 3. 1 minus 2 is minus 1, minus 1 minus 3 is minus 4. So when x is equal to 1, y is equal to minus 4. And y is equal to x squared minus 2x minus 3. Let x be equal to 3. So y is equal to 3 squared minus 2 by 3 minus 3. 3 3s are 9 minus 6. That's 3, 3 minus 3, 0. So when x is equal to 3, y is equal to 0. Part 2. On the same axes used in part A, draw the graph of y is equal to x squared minus 2x minus 3. So we now have these 7 values. So what we want to do is plot the values, minus 2, 5, minus 1, 0, 0 minus 3, 1 minus 4, 2 minus 3, 3, 0, and 4, 5. And let's draw a line through it, which shows a curve or a parabola. Part 3. Using information from your graph, complete each of the following statements. The minimum value of y equal to x squared minus 2x minus 3. That means the parabola that we just drew, the minimum value of it occurs when x is equal to, and you can easily identify, let's put a blue arrow to show us where is the minimum value. It occurs when x is equal to 1. The values of x for which x squared minus 2x minus 3 is equal to minus x plus 3. So what that means, let's recall y is equal to x squared minus 2x minus 3. That means that's the curve for the parabola. And y is also equal to minus x plus 3, which is the straight line. So where do the graphs intersect? Let's identify it with a yellow line there. This yellow arrow shows us it intersects when x is equal to minus 2 and when x is equal to 3. Those are the 2 points of intersections. So if they gave us 2 simultaneous equations, one being a quadratic and one being straight line, then if we're solving it, those would be the 2 x values that we would have gotten. May 2017, number 4a. The function f is defined as f of x is equal to 1/3 x minus 2. So let's put it as a flow diagram so students can get another perspective of how this is done. Let's say the first box is the input, and our input will always be x. And what do we do next? We divide by 3, which is the same thing as 1/3 x. So after dividing by 3, then we minus 2, and that will give us our output. And our output in this case is known as f of x. Part 1. Find the value of f of 3 plus f of minus 3. So let's recall what's the formula. F of x is equal to 1/3 x minus 2. So f of 3 plus f of minus 3, let's substitute. F of 3 will be 1/3 times 3 minus 2. Remember, we're replacing the x by plus 3. Plus 1/3 times minus 3 by minus 2. Right? In both cases, we're replacing the x by these values. And the first term, 1/3 of 3, 3 into 3, 1, 1 minus 2. That gives us minus 1. Plus, in the second set of brackets, 1/3 times minus 3, 3 into 3, 1. So that gives us minus 1 minus 2 is minus 3. So minus 1 plus minus 3 will give us minus 4. Part 2. Calculate the value of x for which f of x is equal to 5. So let's write our formula. F of x is equal to 1/3 x minus 2. And if we think about our flow diagram, what does this 5 mean? The 5 is the output. So what we're really trying to find is what is the input x that will give us our output of 5. So we can do it 2 ways. The first way, after writing the formula, f of x equal to 1/3 x minus 2, let's substitute. So f of x is 5 is equal to 1/3 x minus 2. And we just want to find x, so we need to move everything from the right-hand side across. So the first thing we move is minus 2. When we bring it across, it will be doing the opposite, which means it will be adding. 5 plus 2 is equal to 1/3 x. So if we want x alone, we need to get rid of the 3 on the right-hand side, or the 1/3. The 3 is dividing, so when I carry it across, it will multiply. So it will be 3 times, what did we have? 5 plus 2. And 5 plus 2 is 7, 3 sevens are 21. So x is equal to 21. Or we could say it, let's look at the flow diagram. How could we have gotten an output of 5 on the right hand side in our fourth box? We had to minus 2 to get 5. So if we were going backwards, 5 plus 2 would give us 7. Instead of dividing by 3, if we're going in the opposite direction, we'd be multiplying by 3. So 7 3 are 21. Therefore, input should be 21 to give us an output of 5, which is exactly what we just got. X is equal to 21. And part 3, determine the inverse function f inverse x. So it's the same sort of working. We're finding the inverse, meaning that if we started with the output where that box is on the right side and we're going backwards, what function will give us the opposite direction of what we have? So f of x equal to 1/3 x minus 2. Find x. Then we need to carry the things across. So f of x plus 2 is equal to 1/3 x. X is equal to 3 times f of x plus 2. And we can switch it around. So 3 by x plus 2 is equal to f inverse x. May 2017, number 4b. The graph below shows two straight lines, L1 and L2. L1 is going upwards to the right, and L2 is sloping downwards to the right. Line L1 intercepts the y-axis at 0, 1, meaning the x value is 0 and the y value is 1. Line L2 intercepts the x and y axes at 12, 0 and 0, 6, respectively. And we can see all these things from the graph. Part 1. Calculate the gradient of the lines L1 and L2. So let's recall the gradient of any line. In this case, gradient of line L1. We'll call that M1 is change in y over change in x. So if we look at line 1, we need to take 2 points. So let's take 2 points very far apart. So let's look at the point of intersection on the x-axis. And we move to the right. So we move 6 places to the right. And then we go upwards until we intersect the line, which will be at 13. So we'll be moving from 1 straight up to 13. That means we're moving up 12. So the change in x is 6, and the change in y is 12. So if we substitute in there, m1 is equal to 12 over 6, and 6 into 6, 1, 6 into 12, 2. So m1 is equal to 2. And if we follow the same format for the gradient of line 2, m2 is change in y over change in x. And if we take the y-intercept, and we move across 10 spaces to the right, and then we come down until the point there, then it'll move down 5 spaces. So the change in x is 10, and change in y is minus 5. So if we substitute, we get minus 5 over 10, which works out to be minus a half. Determine, in part 2, the equation of the line L1. Y is equal to mx plus c is the general equation of any straight line, and let's substitute what we know. We know the gradient of line 1, which is m1. We just worked that out. That worked out to be 2. And it cuts or intercepts the y-axis at the value 1, which is c. So we can rewrite y is equal to 2x plus 1. M is 2 and c is 1. And for the last part of the question, what is the relationship between L1 and L2? Give a reason for your answer. So let's look at the gradients. M1 in part 1 worked out to be 2, the gradient of line 1, and the gradient of line 2 worked out to be minus a half. So if we find M1 times M2, that will give us 2 times minus a half, and that works out to be, the 2 cancels 2, so you're left with minus 1. Since the product of the two lines gives a value of minus 1, this indicates that L1 and L2 are perpendicular to each other, meaning they form a 90 degrees to each other. May 2018, number 4a, the function f with domain a equal to 1, 2, and 3. And what does that mean? It means the x values, that's what the domain is, for this function are 1, 2, and 3 only. This is given by f of x equal to half x minus 3. So if you draw a flow diagram, we can see the input is x. And then how do we get a half x? We divide by 2, and then we minus 3. And that will give us our output, f of x. So part 1 of the question, what is the value of f of 1? So we know the formula f of x is equal to half x minus 3. F of 1 means that the x or the input is 1. So let's calculate. We can substitute x is equal to 1. So we get f of 1 is equal to half times 1 minus 3. A half of 1 is a half. A half minus 3 will give us minus 5 over 2, or minus 2.5. Let's put it in the flow diagram and see if it also works. If the input is 1, then we divide by 2. We get 1 over 2, which is a half. And then we minus 3. And that will give us the same output, minus 5 over 2. Part 2. Find the value of x for which f of x is equal to minus 2. So in this case, the output is minus 2. What is the input value, x, that we need to get that output? F of x is equal to half x minus 3. So minus 2 is equal to half x minus 3. And if we want to get x now, we need to keep that alone on the right side. So we need to move everything else across. Minus 3 is on the right side. When we move it across, it will become plus 3. So we get minus 2 plus 3 is equal to half x. That works out to be 1 is equal to half x. So x is equal to 2 times 1. Remember, the 2 is dividing on the right side. When I carry it across, it will multiply. So 1, 2 is 2. Therefore, x is 2. Let's put it into the flow diagram and see if it works. If the input is 2, and we divide by 2, 2 into 2, 1, and we minus 3, 1 minus 3, it gives us minus 2, which is exactly the situation in part 2. For part 3 of the question, an ordered pair for the function is expressed in the form a, comma b. So the x value will be a and the y value b. Using your answers to a part 1 and part 2, or otherwise, list the ordered pairs for the function f. So from part 1, we know the ordered pair. The x value was 1 and the y value is minus 5 on 2. So that's the ordered pair. From part 2, we also know the ordered pair because x worked out to be 2 and f of x, or the y value, worked out to be minus 2. And we just need to work out for the third one, when x is 3. Let's write our formula. F of x is equal to half x minus 3. F of 3 is equal to half of 3 minus 3. 3 on 2 minus 3, which is minus 3 on 2. So the ordered pair is x is 3, y is minus 3 on 2. And for the last part of the question, part 4, explain why f of x is not equal to 5 for the function specified. For this particular function, let's recall that the domain is 1, 2, and 3 only. And in part 3, we got the y values, which were minus 5 on 2, minus 2, and minus 3 on 2. Therefore, 5 is not part of the y values, not part of the range. May 2018, number 4b, part 1, solve the inequalities. Part A, 3x minus 1 is less than 11. So if you want to solve this inequality, we want to find out for x alone. So we need to move everything across on the left-hand side, isolating the x. So the first thing to move is minus 1. When we carry it across, instead of subtracting, it will be adding. So we get 3x is less than 11 plus 1. So 3x is less than 12. And if we want x alone, the 3 is multiplying on the left-hand side. When we carry it across, it will divide. So it will be 12 divided by 3. 3 into 3, 1. 3 into 12, 4. So x is less than 4. So x is less than 4 is the solution to the inequality 3x minus 1 is less than 11. For part B, 2 is less than or equal to 3x minus 1. So we want to find for x alone on the right hand side. So let's transpose and move everything else across. So the first thing to move is the minus 1. On the right side, when you carry it across, it will add. So we'll get 2 plus 1 is less than or equal to 3x. So 2 plus 1 is 3. 3 is less than or equal to 3x. So if you want x alone, it will be 3 divided by 3. 3 into 3, 1. So 1 is less than or equal to x. And for the last part of the question, part 2, represent the solution to 2 less than or equal to 3x minus 1 less than 11. So if we look at the first part, 2 is less than or equal to 3x minus 1. That was actually part B, where what we recognize, 1 is less than or equal to x. So we can draw that. We can say that x can be 1. So we can draw a solid circle at 1. And since 1 is also less than x, that means x is more than 1. So it's going to the right. So we draw this solid circle to say 1 is equal to x, or 1 is less than x, means the line is moving to the right. Now how far do we go? Let's look at the second part of the question. 3x minus 1 is less than 11. And that was done in part A. When 3x minus 1 is less than 11, it's similar to saying x is less than 4. So we can draw a circle at 4, but notice It is not equal to 4, so we don't make a solid circle. We make a hollow circle to show that x is less than 4, but it's not equal to 4. And if x is less than 4, it's going to the left. We've now come to the end of CSEC past paper questions in the topic of relations, functions, and graphs that occur in section 1 of the paper. In our first video, we did past paper solutions from 2009 until 2013. And in this video, we did the next 5 years from 2014 until 2018. And our next video will be from 2019 onwards. Don't forget to look at the description down below to get an outline of all the videos that we recommend, the order to go through the solutions, for you to get a better grasp of the CSEC math paper.